Hello everybody and welcome back to part 2 of the Tween Visualizer Coding Challenge. Last time we went over how to create a quick visualizer of these various tween transition types as well as the easing types, and it allows us to plot these position over time of the tweens so that we can better visualize them. But as we see from our sort of mock-up, we were able to get the actual visualization window complete, but we didn't get any of the controls done. So there's no way for us to change what exactly it is we're visualizing. And we also wanted to add a new feature, and I'll just put it as a checkbox right there. A new feature that's just a checkbox, so a Boolean value. And we wanted it to be the fade feature. So with fading, what I mean by that is as the pixel's drawn, we want the trail behind it, the tail, to sort of fade away, so that way as it draws multiple times you can sort of watch it as it goes. So we want to be able to toggle that for our tween visualizer. So let's just hop right into it. So I've already got the project up from last time. Feel free to catch back up by watching the previous video, or you can just follow along if you're welcome, if you're okay with that. But let's go back to the tween visualizer. So we want the visualizer to be able to sort of fade away the color. Let's start with that. Now we already have this image here, and the image is sort of the entire buffer of pixels that we're going to be drawing. And the way we do that is we feed the image into an image texture, and then we call this draw texture for that image texture. So if we have this image and we're already setting a particular pixel to be our desired color, then before we set that pixel, if the fade feature is enabled, then what we would like is for all of the other pixels in the image to decay. And then once we've decayed everything, then we can go ahead and set our newest pixel and go from there. So first thing we got to do is we got to export our new variable. So we can just do export, and we'll make it a public bool, or we'll just do bool and fade, and we'll give it get and set, and then we will set its value to true, just so we don't have to turn it on. Oops. There we go. And now with fade enabled, we got to check to see if we can do that that fade decay. So first let's check if fade. Oops. So if we have the fade, we want to go over each pixel in the image and decay the alpha value a bit. So there's going to be two ways to do this. I'm going to warn you now. There's more than one way to go ahead and do this. So I'm going to do sort of the first way that I came up with, and then I'm going to go over why it's not a good idea and what the solution for the problems that it has are. So to fade the image, what we're going to do is relatively simple. We already know the image width and the image height. So what we can do there is we can do a for loop and do, let's do row first. Row will be less than the image dot get height. And then we'll increase row. And then we'll do the same thing for the column. And that will be image dot get width. So we're iterating over each row and each column in the image. Switch these to vars. And for every row and column, we're going to do sort of what we're doing here is first we got to lock the image beforehand. Image.lock. And then when we're done editing these pixels, we'll unlock it. But we want to get whatever the previous value for that pixel is, decrease the alpha by some amount, and then write that pixel value back. So to do that, we can just do var previous color equals, and then image dot get pixel, and we can give it the row and column, or I guess it'd be column for X and row for Y. And then now that we have the previous color, we can do previous color dot alpha. We minus equal to, we'll just make a variable called fade amount. So let's just make a new, let's export it. Export a public float fade amount. And let's just start it at, I don't know, 0.1. Oh, and we'll make it a floating point number. There we go. So we have the previous color. We can take its color and subtract it by some fade amount. And then we can just do image.setPixel, give it the new color, and then we'll set the column and row beforehand. So we take every single pixel, we get the previous value of that pixel, we decrease the alpha to sort of fade the color away, and then we set that pixel back with the new color. So let's give it a look. We'll go back to the Godot engine, we'll hit play, and what we expect to see is the lines sort of being drawn, and then over time the tail should fade away. So here's, you can kind of see for some reason it's not being very continuous. It's only got the discrete values, and we'll go over that in a bit. But the most important part is if you watch each of these dots, you can see that they slowly fade away. So the fade is working. But there's the big problem. It's taking so long to fade all of these pixels that by the time the screen updates, the frame rate is so low that the tween has to jump to keep up with the timeline that we gave it. So the tween here on the tween player, this one we said it should take 3 seconds for it to animate. It wants to always take 3 seconds. So from the top left pixel to the bottom right pixel, it's always going to take exactly that time limit. So it's going to jump ahead to make sure it accounts for that. Now, there's other ways we could go ahead and fix that. We could make, instead of using a tween, we could code the progress value ourselves. But either way, we're going to run into this problem where there's a big frame rate loss by doing the logic that we're doing. And yeah, if you see as I move this around, hopefully it captures, you can see that moving it around even jumps around. So there's something going on that's being awfully slow. So let's review the code again. We're not doing a whole lot. All we added was this fade, and we're just iterating over rows and columns. Iterators are pretty quick. I mean, the image it's big, but it's not gigantic. We're not working with 4K resolution here. And we're just grabbing a color. We do a simple subtraction on the alpha channel, and we set the color back. So if the iteration is quick and this integer math is quick, and we could even profile this and get use the profiling tools in our IDE to get a better idea. But we're seeing that this get pixel and set pixel, those are the kind of the last pieces of the puzzle left, and they aren't exactly, there's not much we can do about them. They seem to be what's slow, and how can I redo get pixel and set pixel? So the short answer is, and you can read the documentation and everything to figure this out, but get pixel and set pixel are pretty expensive. They're not particularly quick, and we're telling the image to look up its full image data at every single pixel, and then we tell it to set that pixel back. We're not really taking advantage of the speed that C# even gives us, and that we could do by directly affecting the image data. We're kind of using this proxy function here and just setting them one at a time. So these two lines here are where we're running into trouble. So what we can do is, instead, the second way of affecting this image is, instead of getting every pixel and setting every pixel, the image object has a special property here called data. Now, once again, I recommend you go read the documentation on the image object in Godot. But here we can see it holds all of the image's color data in a given format. Well, color data would be the colors for the pixels, red, green, blue, in the alpha channel. And the given format describes what that looks like. So fortunately, when we created the image, we were able to pass in the format, image format. We have RGBA8. So because we picked RGBA, that means there's 4 channels per pixel, and 8 means that each channel has 8 bits. So it's a single byte. So if we do the math, say we have 100 by 100 pixels, each of those 100 by 100 pixels has 8 bits, and each of those 8 bits is duplicated 4 times, one for each of these channels. So as you can see, there's a lot of data for us to go over, but what we'll find is because iteration and simple math is so quick, iterating over all of those, which we're doing anyway, is going to be so much faster that our frame rate issue will be solved. So let's go ahead and do that. So we were looking at the image data. So let's get image data equals the image.data. And in fact, we can do get data. And what get data does is it returns a byte array. So a byte, very simply, is 8 bits. If you're interested in how registers work, I recommend you go look up plenty of tutorials about it. But basically, we've got 8 bits, so 8 zeros or ones, and we've got some array of them. But the question is, how many bytes do we have? Well, since each byte represents a single channel and each pixel has 4 channels and we have some number of pixels, then that means as we iterate over these bytes, which is just a one-dimensional array, each 4 bytes represents a single pixel, and there will be just some number of pixels. So if we have 4 bytes, then just to use as an example, suppose we had data for first pixel at 0, 0, so the very top left pixel, then image data of 0 equals the red channel byte. And we have the same thing for green and for blue. So this would be the green channel byte, and this would be the blue channel byte. And then finally, because we have an alpha channel, image data of 3 would be the alpha channel byte. Oops. And then if we were to do this again, say on the second pixel, which would be x of 1, y of 0, then instead of 0, 1, 2, 3, we would have 4, 5, 6, and 7 for the red, green channels, blue channel, and alpha channel for the second pixel. So what we can see here is because we want to fade the image out, we really don't need to worry about the red, the green, the blue. All we really need to worry about is the alpha channel. So looking at the indexing here, if the first alpha channel byte is at 3 and the second alpha channel byte is at 7, then we can go ahead and iterate over all of these bytes, so start with the third byte and then do every 4 bytes afterwards. And then we can access the alpha channels of every single pixel in the image. So we're not going to use all of this here. Let's get rid of it. And we'll keep these for now, but we'll eventually get rid of those. But what we can do is make another for loop. We can call it pixel index. And the pixel index goes from 0 to however many bytes we have. So image data dot length. So we don't even need to worry about the width or the height of the image. We just know that there's some length of pixels. And instead of starting at 0, we'll start at 3 because that's the first alpha channel byte. And instead of iterating over 1 byte at a time, we can do the pixel index plus equals 4. And so that means that we'll start at 3 and then we'll add 4 to it. 3 plus 4 is 7. So we'll get to 7 and then we'll continue that. So now we have a way for us to iterate over every single byte, but only the alpha bytes within the whole image for every pixel. And then we can do it very simply. We get the image data of some pixel index. So I can do var byte or alpha byte. So now we have a byte that is for that index. And then we can do some very simple byte algebra, and we can just do alpha byte minus equals fade byte amount. We'll call it fade byte amount as a new variable. And since alpha byte is a byte and the fade byte amount is being used to transform it, then we'll just export a public byte called fade byte amount. Oops. And we can start with just the smallest fade amount, which is 1. So since we only have 8 bytes, we have a limited number of values, and they have to be this integer value. We can't do a floating point value. So the smallest we can fade would be 1. So we'll just start with that. And so the alpha byte, we decrease it by the fade byte amount. And we'll have to do one more step, but I want to show you what happens if we don't do it. But what we can do is we can take the image data at the pixel index, and we can assign it to this new alpha byte. So now we're directly manipulating this byte array with the new alpha values. And so we're not worrying about all 3 channels like we were doing with getPixel. And we can index directly on this array as opposed to using some proxy function to access it. So we don't have to worry too much about the performance impact of that. Now, this image data, it is a copy of the images, or this byte array is a copy of the image data itself. So we need to assign the image back for that data. So once we've manipulated all of the data, we can just simply go to image.setData, create from data. And that gives us a way for us to feed in this byte array here for the last parameter. So if we're going to create from data, we know the width and the height. That's just simply going to be the rect size. In fact, what we could do is even do image.getWidth and image.getHeight. So that gives us the width and the height of the image that we previously had. And then what we can do is tell it to use mipmaps. We don't need mipmaps. The format, we're going to use the same format we used before. So RGBA8. GBA8. So we want to use the same format so it aligns with the byte data we had. And then finally, we can just feed in that actual byte data that we've mutated, which will be image data. So now we've got a new image that's the same size as the old image, same format as the old image, but uses this new mutated image data. And we can get rid of these here. So instead of our old iteration logic, we have our new iteration logic, which will hopefully be a lot faster. Let's save it. We'll run it. And we'll take a look. And now be warned, this might cause a lot of flashing because I expect us to get a bug. Oh, we're getting some sort of an error here. Let's see. Why am I calling set pixel? Well, so we have the black screen, so there's something wrong going on there. But you can tell that, oh, here we go. See how everything's lightening up? And then, oh, it went back to black screen. So what's going on there? Well, because, and we also have the other line, so that's good. But because each pixel that we're manipulating, we're not just affecting the pixels that we've drawn, we're affecting the pixels of the entire image. When we do this alpha byte minus equals some fade byte amount, then with height, that should be fine. What we can do is set a debug point here, and let's debug it, and you'll see something interesting happen. So when we get here, the alpha byte is currently 0 because when we create the initial image, it's full of empty data. So the red, green, blue, and alpha channels are all 0. And our fade byte amount is simply 1. But when we call 0 minus 1, instead of it staying at 0 or going, there's no such thing as a -1 for a byte. We actually have an underflow, and our byte flows over to 255, which is all ones, which is the maximum value. So now we have an image with 0 for the red, 0 for the green, 0 for the blue, and 255 for alpha, which is the full black color. So to do that, all we really need to do is add another check, which is if alpha byte is, before we do the subtraction, we can just do if alpha byte, if it equals 1, oops, I got my logic or my syntax there wrong. If alpha byte equals 1, if it equals 0, then there's no need to subtract it. It's already completely invisible. So we can just continue. There's no need for us to do anything with that byte. So now we only do the subtraction on bytes where there is an alpha value. And now we don't have to set any of that data either if it happens to already be 0. So let's give that a shot. In fact, we can come back and hit play here. And hey, we don't have that big black screen anymore. And we can see that we've got all 4 of our lines being drawn. We got the green, the pink, the orange, and the blue one's a little hard to see. This is just because we're setting a single pixel value though, but it eventually comes up, and maybe what we'll do is change the background color to be a little easier to see. Either way though, you can also see just kind of barely that the pixels are fading away at the rate of 1 per frame. We can make them fade away a little faster. Doesn't really matter. But here we can see the frame rate is much faster. Our gap between dots is pretty small. And we've got the fade away feature. So we were able to get that to work. Yeah, let's change the color of this one. So let's do that really quick. We know that we set the colors here in the Multi-Tween Player. And there was this map here from an easing type to a color. And it's this purple one that's pretty hard to see. So maybe we can just do cyan. Let's rerun it with cyan, and it should be a little bit easier to see. There we go. So we got the cyan one, green one, pink one, and orange one, and we've got all 4 of these. Now, one thing we noticed last time was it's drawing from the top left to the bottom right. We kind of want to flip that. So we want to do whatever the height is here of the image. We want to do sort of a negative. We want to start from the bottom left and go to the top right. That's a pretty easy fix. So when we got the y coordinate of our pixel that we're drawing, that's just going to be, tween visualizer. When we get the y pixel here, we can just do pixel y equals, and then we can invert it. So we'll just do image.getHeight minus pixel y. So if pixel y is 0, then it will be at the height of it, which will put it at the bottom of the screen. And if the pixel y is at the highest possible value, then it'll come out to 0, which will put it at the top of the screen. And let's give it a try. There we go. So now it starts at the bottom left, and they all wind up going up to the top. So hey, look at that. One thing that I'm noticing right now is we're drawing at the very bottom left corner and the very top right corner, which is fine because usually the boundaries of the tween are going to be from 0 to 1. But let me just show you an issue that we're going to have, and I recommend that you try solving this yourself. There's a number of ways to do it. But one thing we're going to notice is if we switch this to something that maybe goes outside of the boundaries, for example, elastic goes outside of the boundaries on the top and the bottom, then it's going to go off the screen. So let's switch it to elastic, and let's rerun it. And if you watch the pixels, they're going to go off the screen for a little bit. Oh, no, it's not going to do it there though, because I need to set you to elastic. And let's run it. There we go. So see how the orange goes off the screen, the green goes off the screen, the pink and the blue are easier. They're on the screen more, but either way, we're going off the screen. So the way you could do that is limit the boundaries of your control and sort of the region that we're drawing onto. Make it a little tighter so that way you have a margin around it, and then when you go off the side of the canvas, you still have the margin to draw onto. But we're not going to solve that right now. It's just something to keep in mind. You could just scale the whole thing down. There's a number of ways to solve it, but it's just something to think about, because even though we're doing the interpolation from 0 to 1, there are certain interpolation patterns that will get us outside of those boundaries. So anyway, moving on. So we added the fade feature, and we have the way to draw these things. I guess the only thing that's really missing is we don't have our controls. So from here, we're kind of going to skip over. We're not going to skip over, but we're kind of done with how to draw things on the canvas and how to use tweens. And we're going to move on to just a very quick and dirty user interface. This would be a good experience for those who are trying to set up little tools or visualizations like this, or just want to learn how to do user interfaces on a basic level. This is a good way to do it, is sort of set simple things up like this. So our tween player has been our main scene, and currently it has only one thing. I guess has the tween, and it also has the multi-tween player sort of sitting underneath of it. So we need to add a couple things to help organize our player. Now, when we were talking about this, we had sort of 3 vertical boxes. We have this one here at 1, 2, and 3. And these are aligned vertically with various, they stretch out and take as much space depending on their setup. But basically, we have 3 things stacked on top of each other. So to do that, we can add a node and we can look for a VBox. And this VBox container is a vertical box container. And that helps us with aligning things vertically. Now, we'll want to set the VBox to take as much screen as it can. So we'll click on the layout button, click on full rect, and now the VBox takes its full space. And we had said that there's going to be 3 things in that vertical box. We've got the controls, we've got the main window, and we've got the playback. So let's add, we want to add controls for each of these. Now, these, let's just start as the top as an example. The control panel here sort of has 3 things in it. It's got this first combo box, it's got this area here with the checkboxes, and it's got the fade control. Now these are aligned horizontally. So similar to how we use the vertical box container, we want to use the horizontal box container in here to get these. So we can do that simply. We can do hbox. That gives us a horizontal box container. And just for now, since we know we're going to need something like, it's called an option, which is the combo box in Godot. Since we know we're going to need one, I'm just going to put it in there so that way you can see how it's going to sort of take as little space as possible here at the top of the screen. We then have the Multi-Tween Player. Since that's going to be below this hbox container, we can just drag it in, and now it is going to take as little space as possible. Now we want the Multi-Tween Player to take whatever space it can, so we only have what's necessary for the controls on the top and the bottom. And so to do that, we can go to the Multi-Tween Player, go over to its size flags, and we can say just expand and take as much space as you can in both the horizontal and the vertical dimensions. So now we have the hbox container, which we'll call controls. We have the Multi-Tween, which is just taking up the rest. And then finally, we said that we wanted a playback section down here. And we can do that. We can add a new horizontal box. We can call this one playback. And similar to what we did before for the controls, we're just going to add an option just so that we can see it take its size. But now we can see that our controls panel up here takes up a certain amount of space. Our playback area here takes up a certain amount of space. And then everything in between is this Multi-Tween Player. Now we've done some organization here, and since we were using the tween player, we were grabbing the Multi-Tween Player here. We need to adjust this path. So we can do that here by just, where is the copy node path here? And if we come back, then this will give us the new path, the VBox container / Multi-Tween Player. So that way, if I change nothing else, I can come through and hit play, and we should be in the same boat we were before. Yep, so now it's drawing those, and you can see that they don't go to the very top quite yet because they have that space reserved for these option boxes here for the top and bottom controls. So, okay, we've laid out in a basic sense our controls. Now let's just go with the simplest one. We have this playback panel, and it has 2 option boxes, this transition type and the easing type. So to do that, we'll just want to put 2 options. So we can do, let's call this one playback transition type. And we'll add another option here called playback, and it will be easing type. So I've just shortened it there, but we've got the 2 of these. And we'll want to dynamically fill the possible options with these in our script so that they have the options that are all of those enumeration values for all of the transition types and all of the easing types. But for right now, just so that we can keep track of them, I will just put some dummy text in here called transition type and some dummy text in here called easing type. And they're right next to each other, so maybe what we can do is put a spacer. Let's see what it's called, a separator, something like that. Separator, yeah, let's put in a vertical separator between them. And then what we can do is do the same thing and tell it to expand and take as much horizontal space as possible. So now these two are pretty far away. So let's just duplicate it and put one on either side. There might be another way to do this, but hey, we've at least got them sort of organized. So that's good enough for now. And let's get started on the UI. So this isn't going to be a full-fledged tutorial on how to do UI, but in a simple sense, we're going to populate the possible options for both of these controls, and then we're going to listen for when they get changed. So let's first set up the listening. To do that, you can click on your combo box, go to the node, and we want to hook into when this item selected changes. So if you double click on this, and then we can click on Tween Player. First, I'm going to copy the method name so we can have it. But if you click on Tween Player and press connect, then now we have a function connection on our Tween Player that we can use to access that callback for the event or the signal. So to do that, we just do public override. The function we copied the name was called onPlayback transition time item selected. And we do know, just based on the node itself, it has one parameter for the index. So we can do int index here. And this gives us a way to have a callback when this is called. I forgot to put void in there. Yeah, I guess it's not an override. There we go. So I can just do something like gd.print the index. And let's just put a breakpoint there. It's just so that way we can see if something gets selected. We might even be able to pick it without having any real options. So if I click, yeah, there's no options there. So let's go back and we've got to populate these options. To do that is relatively simple. We're back at the Tween Player. We want to set it up when we are ready to go in the scene. So to do that isn't going to be too crazy. Let's look for, here we go. So what we want to do is add options to that options combo, and we want to do it for each of the enumeration values in that tween transition type and easing type for one of those respectively. So let's just start with the transition types. And for the transition types, we will just get the combo or the option panel, the option box. So we'll just call playback TT for the playback transition type options control. And we'll just call find node, and we need that path to that node again. So we can just right click here, go copy node path, paste it in, and we'll just typecast it as an option button. So now we have access to that transition type option button, and we can just now iterate over all transition types. Now, to get the possible transition types, there's going to be a little bit of funny business using the enumeration class, but we can get transition types. You know what? Let's put it up there, and that will equal, we can call enum, which is the enumeration helper class, the base class, and we can call get names. And this will give us the sort of the string names of all the possible enumerations for an enumeration. So we want the enumeration type for the tween dot transition type. So the transition type enumeration has linear, sine, quint, quart, so on. These are the actual names of the enumeration, not their values. An enumeration value, linear would just be set to 0, sine to 1, so whatever order it's defined in here. But what we know is we don't want to just show 0, 1, 2, 3 to the user. We want to show the actual names. So we can just get a list of all of the strings for those names using this enum.getNames. And then we can iterate over those names and feed them into that playback option control. So I can just do for each in the transition types. We can call it transition type there, and playback TT, we can just do add item. And we can just give it the item, which is that transition type in the name. And that's all we have to do. So if I come back and play this again, we should see that in our transition type, must have gotten the name wrong. Playback TTS. Oh, is it not an option button? That's an option button. Let's double check. Seems right to me. What am I missing? Maybe I need to rebuild. Let's close all those, make sure they save. All right, we're missing something here. What am I missing? VBox container dot playback TT as option button. Oh, this is what I'm doing wrong. I need to do get node, not find node. So don't make that mistake. You want to use get node when you know the path. You can use find node if you want to search for names, and we're not doing that. We know the actual name. So let's try it again. Okay, so here we can see that's set to linear. Now it's only linear because that was the first option and we didn't give it an option. But we can switch through all of these, and you can see here we printed the number that was picked. And that's because we assigned, or when we have this callback here, we're just printing the index. So, hey, look at that, we're able to get the index. Now, what we can just do is feed that new index to the multi-tween player. And we have to do that by first converting the index into the enumeration. So right now it's just a number, but we want the enum. So we can just simply do, we can convert this index by going to the tween, we'll just go transition type equals tween, or tween dot transition type. And this is going to be the type that we're casting it to. So we'll just convert it like this. So now it's going to be a transition type as opposed to just an index. But since an enum is just integers anyway, the conversion is just direct like this. And then we can go to the multi-tween player, set its transition type to be the transition type that we just created. Oops. Right here. And because this transition type setter is used when we create the visualizers, we're going to need to make sure that when it changes, we want to update all the visualizers for this new transition type. So when we call reset, if we already have the visualizers, we don't need to recreate them every single time. So what we can do instead is just move this transition type, or move all of these settings for the visualizer out of this loop. And then we can just do another loop where if this loop creates the visualizers, then the second loop, we can just do it for each of the existing visualizers and set the values like this. And we already know the easing type that should be here actually, which is going to be visualizer. And we don't need to set the easing color because they already have their color. So really, we're just going to update, when we hit reset, we're just going to update the visualizers with the correct transition type. And now, when the transition type is set, we'll need to make a privately backed field here. So we'll do private transition type underscore transition type, and we'll set it to linear. And then this one, when we do the getter, it will just be the underscore transition type. And when we do the setter, we will set the underscore transition type, but equals value. But then whenever it changes, we'll call that reset. So that way we're always reset to the correct value. All right, so we change our transition type into a getter and setter property, and we have this linear option is the default for our privately backed field. And now whenever that transition type changes, we will call reset, and reset will update the visualizers to use the new transition type. Since each visualizer only really needs to track one easing type, we don't need to update that ever. So we can come back, we can hit play. Let's take a look and see what happens. All right, so I did make one mistake. This was supposed to be the playback controls, but right now it's actually acting as the controls for the look for it. You know what tween we're looking at. But at the very least, we can use this as the baseline and say, hey, as I pick different options here, we can see that the tweens that we're drawing change. So here we've got the bounce tween. We can switch it back to the cubic, and as it fades away, it'll be a bit easier to see, but basically we're drawing the cubic line now as opposed to the bounce line that we had before. So hey, we're able to change that and get the drawing to look different. However, that was not for the, that was meant to be for the playback. Now the playback, remember, is driven by a tween. So if I go to the tween player, we have this tween here. That's the one that tweens the progress. So what we can do instead is maybe we make another helper function called public void or private void. Oops, I can't type. And we'll call it update. What should we call it? Update playback. Very simple. And what this one will do is we'll take our tween here, update playback, and we'll give it the transition type and the easing type. So every time it'll be reset, true, and we'll hit start. But before we hit start, we'll just do tween.stopAll just to make sure that there's nothing running. So if the playback gets updated, then we'll be able to see that reflected in the visuals. So when the playback has a new option selected, we're just going to do transition type equals, and we'll do the typecast. So now, in fact, I'm going to leave those there just because I know we're going to need them later. And now when we pick a new transition type, we should notice that the tween that we're visualizing shouldn't change, but the way that it's played back should change. Yeah, and the reason why this is happening is because we had picked linear, and so we don't want to draw linear. Let's just leave it as, let's call it exponential. We'll leave it as exponential, and so now when we play it, it's drawing that exponential curve, and here it's just doing a linear, the time scale is linear, so it just draws consistently across the whole time scale. But if I switch it to example for elastic, we can see it starts really slowly and then sort of jumps to the end really fast. And we can even do bounce, which is kind of interesting. You can see that it starts in the bottom left, bounces back and forth, and then eventually makes it up to the end. Okay, so we can now mess around with that, but I did notice a weird change. The color went away, and I think that's because I forgot to give the visualizer its color dot value. So now they should each have a different color. Yes, now they've each got their colors. So once again, if I do bounce, you can see how I drew it multiple times there, but we'll just switch it back to linear. Okay, so we have a way to control the transition type for the playback. Now let's do the same thing, but for the easing type. So we'll go back to the tween player, and what we'll do is we'll add easing types. We'll get those easing types of our easing types equals enum dot get names for the type of between easing types. And we'll get the playback easing type option equals get node. And same thing as before, we'll copy the node path, put it in there, and we'll typecast it as an option button. And then finally, we'll go over each easing type. And with that easing type, we'll do the playback ET, we'll add an item, which is the easing type. Now we need to get the hook into the signal. So we'll go to the playback ET, we'll go to node, item selected, add it to the tween player, copy this name so we can reuse it later. And we'll do the same thing, public void on, or we have the name copied, and we know that it takes an index because it's the same signature as the other option callback. And we can just do easing type equals the tween.easing type for the index, and then we can update playback and go from there. So if I update the easing type, we should also notice that well, linear, you're not going to notice a change because linear has the same easing types. But if I change it to like ease out, then it'll behave a little differently. It's a little hard to see on some of the weird ones, but basically the playback control is going to match the same curve based on which transition type and easing type. So you're kind of using a tween visualizer controlled by a tween that you're visualizing. So it's something you can play around with to sort of get the hang of. Either way, that's the playback controls, which was the bottom half or bottom part of this. We need to do a similar thing for the top. So we've got an option for the top, we've got all the easings, and we've got the fade button. Let's do the easy ones first. So we can go back to the engine here. We can go to the controls and let's add our separator here. And so we've got this separator. This would be, we'll just call this one TT. And same thing, we'll just give it some empty text. So transition type. And this one also needs to be populated the exact same way we were populating this one. But luckily we're already iterating over them. So we can just go to our loop and we just need to get the TT node. Get node, we'll copy the node path and we'll make it an option button as we did before. And then as we're adding it to the playback one, we'll also just add it to the regular transition type controller. And then finally, we'll connect, this should be TT. This one should just be separator. All right, so it'll connect to TT there. And we'll do the same thing, item selected to the tween player, grab the name for it, come on down here, and we'll make another public void this guy with the int index. And since we had mistakenly done it before, we can just copy those two lines and use that to update it. So now we'll play it again. We'll pick a different, maybe let's do bounce because it's pretty obvious. And you'll see now it's drawing the bounce lines. So we can use this option here to pick which transitions we're going to visualize. The other easy button was this fade button. So that one was a checkbox. So we'll just add a checkbox. In fact, let's do a checkbox, and this one will be fade. Let's duplicate the separator so there's some space between them, and we can give the fade checkbox some text. So now it says fade, and we can connect when the button is pressed. So we don't want to track when it's down or up. We just want to do a high level press. We can connect that to the tween player, go back to it, add another signal connector, public void on fade pressed, and it'll have bool pressed as the parameter. And this Boolean just represents whether or not the multi-tween player should fade or not. So what that means is we need to also add the multi-tween player. It needs to have that property for whether or not it's fading. And to do that, we'll just export the public bool. And if we, same thing, there's really no need for us to ever request it. So we'll just always return false for the getter. But for the setter, what we can do is go over each of the visualizers and set its fade property to be the new value. So now when we set fade on the multi-tween player, it'll update all of the regular tween visualizers to have the fade. So let's play it again. Currently it's not fading. We click on it. We just turned it on, so we need to invert the starting value. But as you can see, it's fading away slowly. In fact, we can switch to bounce, or not that one to bounce. If we switch this to bounce, then what we'll notice is the old lines fade away over time. So if we turn that off and we draw another one, we'll see that the, let's draw the linear one again. We'll see that the old lines stay intact. And so if we draw all sorts of stuff, oh wait, never mind, hold on one second. I need to figure out why that's happening. I'm noticing something weird. Don't need you. Tween player. Well, let's try it. Tween player. We can put a breakpoint on this fade, and let's debug it. All right, so when we click, no, that's fine. When we click fade, what did I miss? Did I forget to actually connect it? Oh. Yeah, what I want is toggled, not pressed. So toggled is what tells us the new value of it. Pressed just says if it was pressed. So let's update this. So instead of using pressed, we'll use toggled, and then that one will give us the behavior that we're expecting. So let's run it. And if we turn off fade, then we'll see that the lines don't fade away and they just stay there. If we turn on fade, then eventually they'll fade away. All right, so we've got the basic controls for bounce and fade, or for the transition type and the fading property in place. But we're going to get a little different. So for the easing, we want to be able to enable and disable all of the possible easing types independently. So that means we're going to need a different checkbox for each easing type. Now, for simplicity's sake, we could get tricky, but instead what I'm going to do is I'm just going to make a grid control. A grid container here is something that lets us align other controls into a grid. So if I put that between the fade option and the transition type option, I can make an easing grid. And we know there's 4 options, so I'd like a 2x2 grid. So we can set the columns to 2, and that means it'll fill up 2 columns at a time. To add things to the grid, it's the same as anything else. You just add stuff to the node, and so we can do a checkbox. And so I can put a checkbox here for in. That's the ease in. We can add another checkbox. I can just call this one in. The other one's out. we can give it the text out. And then if I add another checkbox for in out, see how it's put it down below. So it's filling in the grid for us. Call this one in out, and then make one for out in, and call this out in. So now we have all of these different options. I'm gonna leave it pressed by default so that way everything is visible to begin. But basically, we want to keep track whether any of these are pressed. Now, I could make a different pressed handler for each of these, and that wouldn't be a bad way to do it. But what I can also do is create one handler for toggled. We'll rename it easing toggled, and we can go to advanced. And I can just add a simple integer, and I'll add an integer for the enumeration value for each of these. So I think the order is in, out, in, out, and out, in. So that'd be 0, 1, 2, and 3. So for this one, I can just add the value 0 as a bonus argument to the toggled function and make the connection there. Oops, I gotta pick tween player. And now when I add a new signal handler for that, do public void, I copied the name from earlier. We want to know whether or not it was pressed, but then I can also do int ease type, which is the bonus property that we added. And so now I have a way to track which easing type was toggled as well as the new value. We'll get to that here in a second, but first I want to finish up wiring the rest of these. So this one here has the signal on easing toggled. So we'll go to out and do the same thing. We'll use that same method name. We'll add the extra argument and make it 1. And then we'll go to in out, do the same thing, use the same name, add an argument, make this one 2. And then we'll go to out in, add the toggled, use the same name, add the argument, and make this one 3. So now we have connections to all of these that are using this extra easing type connection for the signal, as well as the usual bool pressed that comes from the toggled signal. So what we need to be able to do is tell this multi-tween player to hide certain tween visualizers based on the options selected. So what we'll do is just make a very simple way to track this stuff. We'll make a public, we'll do a hash set. So a hash set is just a way for us to store unique values in some collection. And so hash is a way for us to store it. Set just means there's only ever going to be one copy of a particular value. So if we give it a hash set of integers, then that means we're only going to have each integer, in that set once. For the for 4 integers, it's really not going to matter what you use, but we'll just use a hash set for now. And we'll name it. Let's just call visible, or let's call it hidden underscore hidden easings. So when the user hides one, it'll be added to this hash set. And we'll just make it a new hash set, nothing special. Let's also make it read only. So when a hash is set to hidden, what we need to do is anytime anything is changed here, we want to tell a particular visualizer not to draw. So let's go here. We can add a public bool should draw equals true to start with. And if should draw is false, so if we're saying that we shouldn't draw, so if, or let's just say if we should draw, then we want to do all this stuff where we're drawing the current pixel. We're going to still create this image texture and draw the whole image texture, so that way we can still have the fading happen. So when you disable something, it'll fade away. But if we are drawing, then we'll draw the new pixels for the trail. So that only happens if we should draw. So when this easings is changed, we will just grab the visualizer at the same index because we're creating these visualizers at the same 1, 2, 3, 4. So then we can just tell the particular visualizer to hide. So what can we do? We can do public set hide easing. I'll do void set hide easing. And we'll do a bool should hide and an integer ease type. So very simple. We can just see if we should hide, then the hash set hidden easings will just add our ease type. Simple enough. Else, hidden easings will remove the ease type. So now the hidden easings will have all the ones that match. And then we can just simply go over for the index of child count. We will, if the hidden easings dot contains the index, so we have a hash set of the integers, so if that integer is in the hidden ones, then we will get the child at that index. We will typecast it as a tween visualizer, and then we will assign its should draw to be false. And in fact, what we can do instead is just, it should only draw if it's contained in the hidden ones. So now we go over each of the visualizers. If it's within the hidden easings, then we tell it to draw appropriately. Okay, so we should update the should hide easing whenever the tween player is updated, or whenever the easing is toggled. So we want to do multi-tween player dot hide easing, and then we'll just pass in the same thing. If it was pressed, it should be hidden. Actually, if it's not pressed, it should be hidden. And the easing type will be the ease type that's passed in. So let's go back and let's try it out. So we have all of them drawn right now. Let's hide one of them. Oh, looks like they're still all 4 being drawn. Let's cancel you. I think there might be something wrong with our signal, so let's double check. And there's something wrong with our signal. So let's go take a look. Oh, it might be because I didn't save. Let's try again. All right, so I've got it backwards. Whichever one's not toggled will be drawn. So they're currently inverted. So we'll just come back here, go to the multi-tween player, and if it should be drawn is if it's not within there. So let's do it one more time. We'll rebuild. And now we have a way for us to draw these visual, these various transition types. And then if we uncheck, let's say we uncheck 2 of these, the in out and the out in, we can see that we now only have the in and the out, which is the orange and the green one. Let's add one quick little helper. It's hard to tell which one of these will be which of the lines. So let's color code them. That'll be pretty easy to do. We have the colors here in the multi-tween player. So I'm just going to move those to my other monitor. And then I'm going to go to each of these checkboxes. I'm going to set a custom color. I'm going to set the font color for in to be green. So I'm just going to pick a green color. Oh, whoops. Let's do, I think it's this one. Nope, not that one. Pressed. There we go. So if it's enabled, then the pressed color will be green. And so in was just some green color. I'm not going to worry too much about matching. Out I have as an orange color. So I can go to custom colors, go to the pressed color, go to, I don't know, orangish. That looks good. In out was cyan. So let's go to colors, pressed, go to cyan here. And then out in was pink. So we'll go to colors, pressed, look for a pinkish color, looks good. And now we have our 4 colors. So we can play it. And we've got our 4 colors here. If I click on the in out cyan color, then we'll notice that the cyan no longer draws, and eventually it fades away. And in fact, if I turn off the fade, without the fade, the line's way more clear. So there's a way to make it easier. Oh, and you know what? The reason why the line's way more clear is we're no longer iterating over all of those bytes like we did before. So since we're no longer running the fade part of the tween visualizer, which is just here, which is a very simple loop, but because we're going over every single pixel, I mean, we're not even doing we're going over every single pixel, but we're only going over the alpha channels in those pixels. Just, avoiding that part of the loop means that our performance increases so much that our lines become solid again. So there's a number of ways that we can improve that and everything fades away. In fact, I think I can think of one more way to do that, to speed that up. So let's try something. So currently we're going over every single pixel and decreasing the alpha value and stopping here. But 99% of the pixels here are always going to be blank because they're not going to be drawn on. So we're spending a lot of time going over pixels that are already 0 and decreasing their alpha value from 0 to 0. So nothing's happening there. So what we can do is say every time a pixel is drawn, we know it's going to need to be faded away. So we should only really worry about checking the fade on the pixels that we have drawn in the past. And as soon as a picture fades down to 0, or pixel fades down to 0, there's no need to draw it anymore. We'll take a break there. I recommend that you walk through this whole code line by line and try it out yourself. Oh, yeah, get rid of that. You're going to learn the best if you try to type all of this stuff in yourself and play around with it and see how it works. But for the time being, we kind of have our visualizer set up. It's not the prettiest thing, but it works. And kind of to recap, we've come up with something that draws all 4 of these easing types or some subset of the easing types for any selected transition type with the colors that are sort of matching this. And it animates them over time, which you can control down here using the playback controls. And the animation is done just with another tween, so it has the same transition type and easing type options here. And you can also have it fade the color away, so that way you can watch the color fade away and sort of track it as it draws over time. For any given X coordinate, which is the time, you can see the various Y coordinates that get drawn for each of the easing types for this particular transition type. For future things to work on, it would be kind of cool to see all of them in a table like we've got here, as opposed to only seeing one of them at a time. So if you're looking for more practice, that's a great way to practice. And otherwise, I recommend you check out the code on GitHub. I'll have the link in the description, as well as any other links to documentation and to the cheat sheet. But yeah, I hope you learned something. This was a pretty big project for something to try to do all in one go. But if you'd like to see more of these things, or if you have any ideas for what new ones could, new challenges to try, please leave a comment below, and be sure to give this video a like and subscribe to the channel if you'd like to see more. So please share this. I hope it can help somebody. If it helps you, let me know. And otherwise, I'll see you next time.